Vale, 23 to 24. நான் கீழே வந்து மதியானம் 12 மணிக்கு எனக்கு கொடுக்க சொன்னாங்க சார். நான் 2023 to 24 சொல்லி மென்ஷன் பண்ணிடுறேன். சப்போஸ் ஏதாவது இருந்தா நம்ம மாத்திக்கணும்.
A very good morning. I welcome Honorable Vice Chancellor, Sir, Registrar, Sir, all deans, directors, professors, members of organizing committee, and dear participants. In today's inaugural session of the conference titled, A very good morning. I welcome Honorable Vice Chancellor, Sir, Registrar, Sir, all deans, directors, professors, members of organizing committee, and dear participants. In today's inaugural session of the conference titled, A very good morning. I welcome Honorable Vice Chancellor, Sir, Registrar, Sir, all these directors, professors, members of organizing committee, and dear participants. Recent developments in mathematics and allied sciences with applications in agriculture and technology. Now I invite the dignitaries for the lighting of lamp, followed by the Goddess Saraswati Vandana.
हे शारदे माँ अज्ञानता से हमें तार दे माँ। हे शारदे माँ अज्ञानता से हमें तार दे माँ। तू स्वर्ग की देवी ये संकेत तुझसे, हर शब्द तेरा है हर गीत तुझसे। तू स्वर्ग की देवी ये संकेत तुझसे, हर शब्द तेरा है हर गीत तुझसे। हम हैं अकेले हम हैं अधूरे, तेरी शरण हमें प्यार दे माँ। हे शारदे माँ अज्ञानता से हमें ताज दे माँ। दुनियों ने समझी है दुनियों ने जानी, वेदों की भाषा पुराणों की वाणी। दुनियों ने समझी है दुनियों ने जानी, वेदों की भाषा पुराणों की वाणी। हम भी तो समझे हम भी तो जाने, विद्या का हमको अधिकार दे माँ। हे शारदे माँ अज्ञानता से हमें तार दे माँ।
Now I request Registrar Sir for the floral welcome of Honorable Vice Chancellor Sir. I request Dean Agriculture Dr. Vivek for the floral welcome of Registrar Sir. Thank you, sir. I invite Dr. Prerna, the convener of the program, for the floral welcome of Dean Agriculture. Thank you, ma'am. I invite Dr. Savan Rawat to welcome Director Research, Dr. Kamal Khilani. Thank you. I invite Dr. Rajesh Bish to welcome Dean PCS, Dr. Gopal. Thank you. I invite Dr. Ajit Kumar Singh to welcome Dr. UP Shahi Dam. Thank you, sir. I now invite Dr. Ajay Kumar for welcoming of Dr. Ravinder Kumar, Dean Biotechnology. Thank you, sir. I invite Dr. Khushbu Roy to welcome the convener, Dr. Prerna. Thank you. I will take the opportunity to invite Dean Agriculture for the welcome address.
Good morning to all. It's my privilege and pleasure to welcome the dignitaries, guests, and other staff over here on the occasion of this inaugural session of National Conference on Recent Developments in Mathematics and Allied Sciences. Agriculture and Technology. I would like to express my profound gratitude to our worthy Honorable Vice Chancellor, sir, and who is the chairman and chief guest of today's function, under whose dynamic leadership, Sardar Vallabhbhai Patel University of Agriculture and Technology is marching forward. Honorable Vice Chancellor, sir, making all efforts to establish this university at global level, and I am grateful to you, sir, for sparing the time to address this gathering and to inspire us in this conference. The participants by advanced knowledge on the different aspects, such as on mathematical modeling, statistical tools, computational techniques, etc. The aim of this national conference is to enrich the participants by providing expert lectures which will give the new directions on recent development in mathematics and allied sciences. On behalf of organizing committee, registrar, directors, heads, family members, participants from the different states, and students and others for their presence in this event. We are very fortunate that we have the different speakers like Dr. Madhu Jain, Professor Mathematics, IIT Roorkee, Dr. J. Nityanand, CSIR Pune, Dr. Vijay Gupta, Professor, NSUIT New Delhi. And on this occasion, who will deliver their lecture in this program, I also extend my heartiest welcome to them. And special appreciation goes to Dr. Prerna Sharma, Professor and Head Basic Science, as well as Organizing Secretary of this National Conference for organizing this event and highlighting the proceedings and forum. Lastly, I would like to welcome to all the members of Organizing Committee and all my colleagues who have been working since the last several days. Welcome you all once, and we look forward for an extremely productive of this national conference. Thank you very much.
Thank you, sir. Now I shall invite the convener of the program, Dr. Prerna, to give an overview of the conference.
Thank you, Dr. Mani. Good morning, everyone. It gives me pleasure to welcome all the delegates, researchers, academicians, scientists, and students to the National Conference on Recent Development in Mathematics and Sciences with application in agriculture and technology. This national conference is being organized in sacred memory of legendary mathematician Srinivasa Ramanujan, whose extraordinary contribution continue to expand traditions of mathematics and sciences across the globe. We are proud to share that approximately 175 participants, including faculty members, postdoctoral fellow, PhD and postgraduate students from diverse institutions across the nation have registered for this program, in which more than 140 oral presentations will be there in 2 days in the field of mathematics and allied sciences. Participation reflects the growing interest in recognition of the critical role that mathematical techniques play in solving complex problems across agriculture, scientific research, and modern technological development. We are pleased to honor to have with us our Honorable Vice Chancellor today as chief guest of the program. I take this opportunity to express my sincere gratitude to the Honorable Vice Chancellor of Sardar Vallabhbhai Patel University of Agriculture and Technology, whose constant motivation, visionary leadership, and encouragement have always inspired us to organize such timely and meaningful academic programs. I would like to place on record my sincere appreciation to the Registrar Dr. Ramji Singh, who has always provided valuable guidance and administrative support for organizing this program. My pleasure to acknowledge the educators who always motivates us to organize this program. I also acknowledge the presence of Dean EGS, Director Research, Dean COB, and all the heads of this departments of College of Agriculture and all the faculty members of our university. We are pleased to announce that online presence of distinguished resource persons from reputed universities and premier institutions who will sharing their expertise with us. Dr. Madhu Jain, a senior professor in an Institute of Technology, Roorkee. Topic is stochastic modeling and intelligent computing for the forecasting and optimal design of fault-tolerant systems. Dr. Vijay Gupta, a senior professor from Netaji Subhash Institute of Technology. He will deliver a topic on construction of operators through different methods. Dr. N.K. Sharma, professor and former dean CSUAT Dawa campus. His topic is solar energy prospect and challenges. Dr. J. Nityanandan, a senior principal sciences CSIR, National Chemical Laboratory, Pune, Maharashtra. Dr. Yogesh P. Senior Sciences CSIR, Indian Institute of Integrated Medicine, Jammu. This topic is agrotechnology of medicinal plants and the development of herbal medicine and drug discovery. Their collaborative contribution will enrich our discussion and provide valuable insights into the integration of technology, mathematics, science, and agriculture and related fields. The objective of this conference is to provide a common platform for researchers and practitioners to share recent advances, innovative ideas, and interdisciplinary application of mathematics and allied sciences, particularly in the domain of agriculture and technology. I sincerely hope that all the participants will find this program intellectually enriching. I trust that the expert talks and paper presentation by delegates will provide new insights, spark innovative ideas, and open avenues for further research and academic collaboration. I take this opportunity to thank our Honorable Vice Chancellor, Stars, Deans, organizing team and all supportive staff for their invaluable contribution in making this program possible. Most importantly, I thank to all speakers and participants for being a part of this academic, and to all the organizing activities of this event. Wish conference a great success. Thank you.
Thank you, ma'am. Now, I would like to invite the Registrar of the University, Dr. Ramjit Singh, for his address.
Most respected and honorable Vice Chancellor, sir, distinguished guests and speakers, members of the organizing committee, esteemed faculty members, dear researchers, scholars, and students. A very good morning and warm welcome to all of you. It is a privilege for me to address this August gathering on the occasion of the inaugural session of this national conference. On behalf of the university administration and on my own behalf, I extend a warm welcome to all the participants who have joined us from different institutions and regions of the country. This conference is being held on a truly meaningful day, that is today, 22nd December, which is celebrated across the nation as National Mathematics Day, in honor of the birth anniversary of Srinivas Ramanujan. While this mathematical genius is widely acknowledged, what makes his life even more inspiring is his enduring dedication to knowledge and his belief that mathematics has a deeper purpose in understanding the universe. Remembering Ramanujan today encourages us to value originality, discipline, and perseverance in academic pursuits. The focus of this conference on recent developments and applications is both relevant and forward-looking. In today's knowledge-driven world, mathematics is no longer confined to classroom or textbooks. Rather, it plays a decisive role in solving practical problems, from improving agricultural productivity and managing natural resources to enabling technological innovations and digital transformation. Mathematical methods provide accuracy, efficiency, and predictiveness in many areas. By bringing together experts from mathematics and allied sciences, this conference promotes the kind of interdisciplinary thinking, the modern challenges which demand very much. I am particularly pleased to see the emphasis on applications in agriculture and technology. These are the two areas that are vital for national growth and societal well-being. Research outcomes discussed here can contribute meaningfully to sustainable development, technological self-reliance, and evidence-based decision-making. Such academic forums help bridge the gap between theory and practice, and between research institutions and real-world needs. I would also like to highlight the importance of academic events like this, strengthening the research ecosystem of our university. Conference provide a platform for young researchers to present their work, receive constructive feedback, and develop confidence. They also foster collaboration among institutions, which is essential for high quality research and innovation. I take this opportunity to appreciate the sincere effort of the convener, organizing secretaries, organizing committee members, coordinators, and supporting staff who have worked diligently to ensure the smooth conduct of this conference. Their commitment reflects the academic spirit of our university. In conclusion, I wish all the delegates a stimulating and productive academic experience for the next 2 days. May the discussions and interactions held here lead to new ideas, meaningful collaborations, and impactful research outcomes. With these words, I wish the conference a great success. Thank you all.
Thank you, sir. Now I shall take the privilege of inviting Honorable Vice Chancellor, sir, the chief guest of today's program, for his address.
Deans and directors, faculty members of this university, organizers of this conference, speakers, and participants. It gives me immense pleasure to welcome you all in 2 days national conference on recent developments in mathematics and applied sciences with applications in agriculture and technology. I extend my heartfelt greetings to all the participants joining us in this academic gathering, and I congratulate the organizers for conceptualizing and conducting this and intellectually stimulating conference and distinguished speakers from IIT, CSIR, central universities, and state cities. This gathering itself is a reflection of our nation's academic diversity and collaborative spirit. Today's occasion is especially significant as we are meeting on 22nd December, the birth anniversary of one of the greatest mathematicians the world has ever known, Srinivas Ramanujan, in mathematicians, scientists, and innovators. In these days, celebrated as National Mathematics Day, reminding us the power of mathematical thought in shaping. Ramanujan's life is a remarkable testimony to the universality of knowledge. With minimal formal training, but extraordinary intuition, creativity, and perseverance, he contributed profoundly to number theory, infinite reach, continued fractions, and mathematical analysis. His journey from Kumbakonam to Cambridge symbolizes the triumph of intellect over adversity and teaches us that original thinking and passion can transcend all limitations. As we honor his day today, we also renew our commitment to nurturing scientific temper, curiosity, and innovation among our youth. Mathematics is often described as the language of nature and the foundation of all sciences. In the present era, its role has expanded far beyond theoretical boundaries. Mathematics and allied sciences now lie at the heart of data science, artificial intelligence, climate modeling, precision agriculture, biotechnology, and advanced engineering. The theme of this conference rightly emphasizes the applications of mathematical tools and models in agriculture and technology, sectors that are crucial for national development and sustainability. Agriculture today faces complex challenges like climate variability, resource optimization, soil health, crop productivity, and supply chain efficiency. Addressing these issues require robust mathematical modeling, statistical analysis, optimization techniques, and computational approaches. Similarly, modern technology from machine learning algorithms to smart farming systems rely heavily on mathematical foundations. This conference, therefore, provides a vital platform for interdisciplinary dialogue where mathematicians, scientists, and technologists can collaborate to develop solutions with real-world impact. I am confident that the deliberations, keynote addresses, invited talks, and research presentations during this conference will not only enrich our academic understanding, but also open new avenues for collaborative research and innovation. Such interactions are essential for translating theoretical advancements into practical applications that benefit society at large. I would like to appreciate the efforts of the organizing committee, advisory committee, and all those who have worked tirelessly to make this conference possible. Organizing academic event of this scale requires vision, dedication, and teamwork, and I congratulate the entire team for their commendable efforts. Before I conclude, I wish to encourage our young researchers and students to draw inspiration from the life of Srinivas Ramanujan. Let curiosity, originality, and fearless pursuit of knowledge motivate you to ask questions and explore uncharted territory of science and mathematics. With these words, I once again welcome all the participants and formally declare the National Conference on Recent Advanced Developments in Mathematics and Allied Sciences with Applications in Agriculture and Technology open. I wish the conference every success and hope it becomes a memorable and fruitful academic experience for all. Thank you very much.
Now I shall invite the convener and the organizing committee members for the presentation of memento to the Honorable Vice Chancellor. I would invite the dignitaries for the release of abstract book. Thank you, sir. Now, coming to the end of the inaugural program, I invite Dr. Savan Rawat, the organizing secretary, for the vote of thanks.
Good morning to everyone present. It is indeed a great honor and privilege for me to deliver a vote of thanks on this auspicious occasion of the inaugural session of two-day national conference on recent developments in mathematics and allied sciences with applications in agriculture and technology. First and foremost, on the behalf of organizing committee, I extend our deepest sense of gratitude to our Honorable Vice Chancellor. Sir, we are truly grateful to you for sparing your valuable time to be with us today. Your inspiring words have always been a source of motivation, and your constant guidance has encouraged us to strive for excellence in both teaching and research. We are indebted to you for inaugurating this program and blessing us with your visit. A heartfelt thanks also go to our registrar, sir, whose constant support has always been instrumental in the smooth organization of this conference. Cooperation in academic and administrative matters make initiative like this conference possible. It is highly appreciated. I take this opportunity administration and monitoring. Your encouragement and goodwill mean a lot to the organizing team, and your commitment to fostering a culture of research and innovation is truly commendable. A very special mention must be made of Dr. Deepak Sisodia, Dr. Uttam Sharma, Dr. Sushil Kumar, Mr. Monu Tomar, and other members of the team of IT Cell. In today's time, when most academic engagements are held in hybrid or online modes, it is their technical expertise and dedicated efforts behind the scene that ensure everything runs smoothly. We are extremely thankful to them for their tireless assistance. I would also like to place on record our appreciation and gratitude to the convener of this conference, Prerna Sharma. Ma'am, your dedication, tireless efforts, and constant motivation have been the backbone of this program. For conceptualizing the idea to carefully planning and executing every detail, your leadership has exemplified. At the same time, I must acknowledge the sincere efforts of my fellow organizing secretaries, Dr. Rajesh Best, Dr. Ajit Kumar Singh, and Dr. Ajay Kumar. The teamwork and dedication have been crucial in shaping this conference and making it a reality. Finally, I extend my thanks to all the participants who registered for this conference from across different parts of the country. Your presence in large numbers is a testimony to the importance of this program, and I'm confident that the coming session will us all with a valuable knowledge and insights. In conclusion, I once again thank everyone who directly or indirectly contributed to making this inaugural session a memorable and successful one. Thank you so much.
I shall invite all the dignitaries for a group photograph.
Very good, fantastic.
Hah? Rezeki. Yang
Ma'am is having an experience of more than 35 years, more than 500 research publications, and many awards like Career Award UGC. She has guided a handsome number of students in the research. She has research interest in the field of computer communication networks, industrial mathematics, mathematical reasoning, biomathematics, and so on. So here we are privileged to have you, ma'am, with us today.
So good morning to all of you. So I am thankful to the Honorable Vice Chancellor K.K. Singh, Dean Registrar of the SVPUAT, Professor Prerna Sharma, for inviting me to present my talk in this conference. So the topic is conference is related to the agriculture application. So here today I am going to present my talk on the topic of the stochastic modeling and intelligence computing related to the fault tolerance system. So let us first share my screen. Can you see my screen? Hello, my screen is visible?
बोल दीजिए माइक ऑन करके बोल दीजिए
Okay.
माइक ऑन
Yes.
कीजिए
Yes, ma'am, it is visible.
Yes, ma'am, it is visible.
Okay.
Audible.
So today I am going to deliver my talk on the topic stochastic modeling and intelligent computing for forecasting and optimal design of fault tolerance systems. So here I am discussing what are the stochastic models and how we can do the optimal control policy by using the soft computing technique or traditional optimization technique. And we discuss some performance measures based on the probability theory and statistical goodness of fit method. And here we are concerned with the survival analysis of the component in any fault tolerance system. Some concept we are using to develop the model, that is the reboot and recovery. We derive some formulation by using the stochastic analysis for the reliability and QN indices. And we discuss the AI technique based on the fuzzy logic and neural network. That is combination of that one is the hybrid technique, neurofuzzy technique and FIS. And cost optimization issue will be discussed also. So what is the stochastic process? Stochastic process is a family of random variable xt, where t is the index set and xt takes the values on the real line. It may be discrete or the continuous random variable. And for a fixed time interval, we have the continuous process. And if we are taking the epochs at t equal to t1 and so on, we have the discrete state space. So there are the four types of the stochastic process: discrete and continuous cases, with respect to the state as well as the value of the index set. So stochastic modeling is very important to develop the model of the real life situation. It may be situation of the life science, agriculture, and computer communication and transportation, and in every field of the real life problems we can apply the stochastic modeling where outcome is unpredictable. For the random events we develop the stochastic models. 90% real life phenomena are the stochastic, not the deterministic. So here we discuss the performance measures for the system which we want to fault tolerance, because every system is subject to failure. By taking the some measures or prevention or the corrective measures, we can make it as a fault tolerant system. And whatever resources is used for the maintenance, we control that one by doing the cost optimization related to the concerned system. And for the cost optimization, we can use the soft computing technique. There are the various techniques available, and it can be used when we have the complex optimization function and there may be the large number of the constant. So first, what is the reliability? Reliability, we are taking the reliability of the fault tolerant system. It is the probability of failure-free operation for a specific time period or input set under a specified environment. Environment we are taking into consideration for the software. For hardware, it is not much important. So whatever failure behavior we can predict with the help of the reliability measures. And sometimes we are also interested in the availability of the system at any time point or during an interval. So there is the point availability as well the interval availability. So here we concerned with the failure of any system and how we can assess the reliability and availability. And sometimes we do that in terms of the movements and the expected values. Failure we are taking in terms of the failure distribution. So those who are concerned with the statics, they know how we can predict the performance measures. So that is with the help of the mean and variances, and some higher movements are also important. So for movement, we can develop the formula X. Here is the stochastic process, random variable. So expectation of XM gives you the mth movement, and expectation of X minus mu X is the mean or the average. So if we are taking the mth movement about the mean, so that is called the central movement. And second movement about the mean is well known as a variance. So we are familiar with the terms mean and variance, but these are the first movement and second movement for the second movement about the mean. So to develop the fault tolerance system, there is need to take the some measures. So first we take what is the fault, what is the failures. In every hardware and software, we have the problem, the faults. Due to faults, the system may be the partial fail or total failure. And sometimes we are interested to detect the fault. So fault may be detected correctly or there may be some error in detection of the fault. So before developing for the design of the system, we are also concerned how we prevent those fault or the failure of the system. So prevention or corrective measures are taken into consideration. Sometimes fault occurs, the system take the protective measures. In case of the software or software embedded hardware, we have the provision of the reboot and recovery, self-recovery also. So we diagnose the system. It may be the hardware system or software system or maybe the hybrid system, software embedded system. So whenever we are doing the operation of the system, that is the function of the system, we continuously examine the failure or the errors and take the corrective measures. So nowadays, AI techniques are used for the advanced system like the computer systems, communication systems, and uh, manufacturing system also. This kind of the technique are used to judge and assess the fault of the system and taking the measures. So one of the important measures to correct the fault or provide the fault tolerant system is the redundancy. That means support of the spare part support. So this is also very important in many systems. So you're familiar that in car we have the 4 tires and one stepney. Stepney is a spare part support. So even in the aeroplane, we are having the provision of the redundancy in case of the engines. So there is the popular architecture, that is the 2 out of 3 systems, and 2 out of system is if out of 3 operating unit 2 are working, system is okay or it is working well. So to make the more fault tolerant systems, we have the K out of N system, in which if we are having the 2 out of K units are working, so that become the triple modular. In place of the triple modular, this become the kth modulus redundant systems. So when we are developing the model, we have the Markovian process and the non-Markovian process. Markovian process is also important to develop the model. In Markovian process, the future state depends on the current state, not the past state. So in that way, it has the memoryless property. So we define what is the Markov chain. Markov chain is a discrete state continuous time Markov stochastic process, and it gives you the probability xt equal to x given the value of the x at different event, different time points or epochs, that is the tn, t1 up t0. So we can say that the probability depends on the current state, that the nth state, not the previous state, that is the n minus 1 and x up to the x0. So if the next state depends on the present states, we have the Markov chain, but here the state space is what we are taking the continuous, but we take the discrete state space discrete, but whatever value of the random variables, it may be the continuous. So first we take a very simple model, how we analyze the availability or the reliability of the system. Say we are having the system or the component which is in 2 state, up and down. So to develop the model, what we take the failure rate and repair rate into consideration. So it is a repairable system. So if it is in up state, it can fail and become the down state 0 with the rate lambda, and transition from down state to up state is possible with the help of the repair, that is the repair rate is mu. So in this case, we formulate the governing equation by taking the balance equations. Balance equation means whatever go outside of any state is the sum of the state that is coming from the other state. So here if we are taking the equations, balance equation for the state 1, so we can say that the whatever come into this state, one state is from 0 with the rate mu. So mu pi 0 is the probability the system is in state 0, and this is balanced by the whatever coming inside to this state from the other state, that is the from state 1. So lambda pi 0, we have that. Similarly, we can write down the governing equations for the state 1. So if from state 1, outgoing is the rate lambda, and incoming rate from the zero, that is the mu p pi 0. But whenever we are developing the stochastic model that is related to the random events, we have the one condition, that is the normalizing condition, that gives the sum of the probability is always equal to the 1. So that equation we are also taking into the consideration. So for this simple one unit system, we have the mean time to failure is the inverse of the arrival rate or the failure rate, and mean time to repair is the 1 upon mu, where mu is the repair rate. So we can get these mean time to failure, mean time to repair for this equation. But we have the large number of equations, due to the very large number of the state of the systems. So for this simple models, we have the just sum of the probability is equal to 1. And by taking the balance equation, simple algebra, we get the your mean time to failure. And if we are taking the availability of the system, so this is the ratio of the mean time to failure to the mean time to failure plus your MTTR. So downtime and repair time we can easily calculate for the 2-unit system. But the state may be the transient. Transient state means it depends on the time. So for 2-unit system, we can obtain the equation for the state 1 by taking the derivative of the probability of being in state 1, that is the P1 dash T. This equal to the whatever go outside from the state 1, that is the lambda P1T, and whatever come inside to this state, that is the here mu P0T. So this is the equation for the state 1. Similarly, we can write out the transient equation for the state 0 or take the help of the normalizing condition, which says that the P0T plus P1T equal to 1. So this, you can see here we have the set of 2 equations. However, one equation is redundant due to the normalizing condition. So whatever set of differential equation, we solve by taking the different analytical method. But when number of states is very large, it is very difficult or not feasible to use the analytical method. In that case, we are interested to use the algebraic Laplace transform approach and then take the spectral method. Or we are taking the help of the numerical method like Runge-Gupta method and others also. So for this simple model, when the state is transient, we take the Laplace transform of equations and then get the value of the probability in terms of the Laplace transform and then take the inverse Laplace transform. That method we are applying for that one. So if we are taking the Laplace transform of the 2 equations, we are getting the this equations here. We are having the 2 equations. So these we are having the, with the help of the Laplace transform, we have these 2 equations into consideration. And initial condition is that system is good initially, that is the P10 equal to 1, so that other probabilities comes out to be 0 initially. So by solving algebraically, we can get the easily the values of the Laplace transform of the probability and taking the inverse Laplace transform, getting the results for the probability. Once we are getting the results for the probability, so we are having the we can get the performance measures because Q size distribution, or you can say the probability distribution, is known. The 2-state model can also solve with the help of the traditional method. In this case, we have the only one equation by using the normalizing condition. So you can see this is the linear differential equation with constant coefficient. So by taking the integrating function, we can solve this one and get the value of the probabilities very easily. However, if there may be the 2 types of the failure, so we can have the 3 nodes system, or we have the probabilities of the good state, fail of type 1 and fail of type 2. So this model can be easily generalized to the multiple failure types, that is the n types of the failures also. So we take how we write down the equation as we discuss. For the three nodes, we can take the balance equations, and those governing equation is also known as the Chapman-Kolmogg equation. So we can formulate this equation for the steady state easily. You can see for the state P2, P1, and for P0, we are not taking the equation because we are using that is the redundant due to the normality condition. Any one equation can be treated as a redundant, and we can use the normality condition. So you can see this is the set of simultaneous equations, and we can easily get the value of the probabilities. And for steady state, we have this kind of the probabilities, but when we are taking the transient state, so we have the derivatives in terms of the derivative of the probabilities of the state in terms of the negative of the inflow and negative of the outflow plus positive of the all inflow outflow. So that kind of the equation. So this kind of the um, probabilities depicted. So you can see this with respect to time. Initially probabilities P2 is the good state. Here P2 is the good state. So you can see the P2, this is a good state. P2 is a good state. So initially it is probability is 1. So you can see from the graph, you can find the same trend for the system. So this type of the model can be generalized to the multiple type of the failures. But in real life, sometimes we have the partial failure and the complete failure. So again, we can develop the model in terms of the three states. So by taking the balance equation, we get the results for that one. As you can see here, there is the three equations simultaneously in terms of the probability of the state. Algebraic solution gives you the value of the probabilities, and we have the results for taking the lambda 2 is equal to 2 lambda. This model is applicable to the 2-unit systems. If the 2 units are good condition, the failure rate from state 2 to 1 is the 2 lambda. So, and if there is only 1 unit is operating, the failure rate we can take as a lambda. So state dependent failure rate can be applied to develop this kind of the model. So here we have the 3-state model by taking into consideration the partial failure and failures. But if we are having there may be some fault are undetected in real life. So in that case, we have the probability that it is detected correctly. If it is not detected correctly, so system becomes the fail in spite of the availability of the other good units. So you can see the model can be developed by taking the imperfect coverage into consideration. So for the previous model, we have the imperfect coverage means with the probabilities 1 minus C, it goes directly to the failed state. Whereas in the previous model, we have taken the perfect coverage, means fault is detected correctly. So sometimes fault is not detected correctly. So this feature should be involved in the development of the fault tolerant system. So for this, again, we are having the set of equations, and that algebraic solution gives you the result for the model, 2-unit models with the provision of the fault coverage is not correctly detected. So again, little bit more general model, we are having the 3-unit system. So we can write down the equations for the 8 nodes for here. So in this area, you can see the two units are operating, first and second, first and third, and the second and third, if they are dissimilar units. And similarly, this node gives you the three nodes gives you the there is the only one unit are in working state. Last state gives you the all the three units are not working. And whereas first state gives you the 111 means all units are in good state. So if units are similar, we can combine the three state into the one state. So you can see this. So we can see second label 110, 101, 011 can be combined into the one state, whereas 100, 010 and 001 is also combined into the single state when one units are in fail condition. So this kind of the simplification we can do for the model. So you can see if units are similar, we can reduce our number of equations. In place of the 8, we are having the 4 equations by seeing the diagram, second diagram. To develop the fault tolerant system, we are having the provision of the redundancy. So this kind of the system can be developed as a K out of NG system. So this says that if out of n operating units, K units are in good state, then system is good. And so you can see when there are more than more than K units, K and K plus 1, K plus 2, and so on, up to n units are available, system is good state. So you can see that this state is the good state, but if they are the more than K units are failed, so number of operating unit, the K minus 1, or all units are failed, so you have this node. So this is the failed state. So you can see this is the failed state. So for this one, we can also take the set of equations. Here transient equations are taken into consideration. And you can see this is not much difficult model because we can get the probabilities of the zero failure in terms of the one failures and so on. So by recursion, we can solve the set of equations by putting the value of the probabilities obtained from the previous equation to the next equation. So solution comes out to be this one. So system is failed state. We are having this results for this one. So now come to the model development. If there are the large numbers of the states, so that can be developed with the help of the bird equation. For steady state, so we have taken the whatever may be the outflow from the state K that is balanced with the inflow from the other states. So this is the generalized equations and this is the bird equations. And for the state 0, we have for this state 0, we have the second equations. This equation gives you the state 0. So for the steady state, we have this equation. If we are having the transient state, to the left-hand side, we have the derivative of the state, probability of the state. So it is a very important equations. But education depicts the many real-life phenomena, including the life sciences, population dynamics. You have the vegetation. In agriculture, we have the physical systems also with the help of this birth education. Birth means whatever coming inside the system, and death means which is going outside the system. So that kind of equation. For the steady state, we can develop the product type solution easily, but for the transient state, it is little bit difficult. So we have used the some analytical method, but when analytical method are not feasible to give the solution, we can use the numerical method into consideration. So why we need the artificial intelligence technique? So here we discuss only very quickly the fuzzy logic, because whatever parameters are there, it may be the not crisp, means there may be the ambiguity. Sometimes some attribute we are taking the not as a number, it may be the in linguistic way, that is the say failure rate is very high, it is moderate, it is low. This kind of the linguistic values we are putting in terms of the fuzzy logic. So fuzzy logic we are using to develop the fault tolerance system also, and it can be used to control the operation of the systems. So repair rate can be predicted in advance, whatever optimal repair is provided, and we can also take into consideration what kind of the redundancy is required for that system. So say we are having the fuzzy parameters, it may be the failure rate, it may be the repair rate, remove rate. So we choose the some linguistic terms. Say here we have the x is a parameter, x is large positive, it may be the 5 values we are taking as the linguistic attributes, we are taking the in linguistic terms, large positive, medium positive, small, medium negative, or the large negative. So whenever we are taking the fuzzy-fied model, and then for the fault tolerance system, it should be the AI based, some expert system we are developing. So that system we call as a knowledge based system. And then we use the if and then rule. So if x1 is true, x2 is equal to true, and x3 is not true, and so on. So then what is output we required? So that we develop with the help of the if then rule, and ANN method is also used for this type of the things. Inference engine we call this one, because it based on the fuzzy inference of on the input, and then we apply the rules, if then rules. So once we get the output, that output is the defuzzified, so that we need to be the defuzzified that one with the help of the some available technique. So whenever we develop the model, we need the data and then check our goodness of fit based on that data. So that data cleaning is very much required, and because different attributes have the different scale, so scaling of that one is done with the help of the normalizing condition. And one of very powerful technique in AI is the regression analysis, and mainly AI technique, machine learning, we are using the 3 types of that classification, and regression is very widely used, and clustering is also used, some method for the clustering used, but forecasting is very important. So we have the forecasting formula for the linear regression case. If they are we have the n attributes, so it is a linear combination of those value of the attributes, and in terms of the some coefficient terms beta i's. So whenever we develop the model, we collect the data, and fitting of the curve is done based on the AI technique for the multiple regression. How we take the fuzzified model? So whatever input value, and then we apply the intelligence to that one, as I discussed with the if then rule. So whatever crisp input values is there, we use the fuzzifier. So whatever fuzzifier input set is there, then apply the rules, intelligence based rules, that is for special case is the if and then rule. Then we get the output, that is the defuzzified output, and defuzzifier is used to give the crisp values. So this kind of the things are done. So this fudgification is quite common. Whatever devices we are using, this is the air condition, dryers, your washing machine, heater, etc. are using this kind of the technique. So here we take the some advanced model. Very quickly, I discuss the model because now we are familiar how we formulate the governing equations. If it is Markovian, process is there. So sometimes whatever repair is provided, that repairman is also unreliable. So that things can be taken into consideration. And whenever repair is provided, if some unit are collected or accumulated, then we start the repair of the system. So that is called the threshold based recovery. So there may be the provision of the reboot and recovery in advanced fault tolerance system. So that should be taken into consideration. Transient analysis is difficult by taking the traditional analytical method, but with the help of the numerical method or AI-based technique, we can develop the model and predict the results, whatever matrices we required for the further control of the system. And for the optimization purpose, traditional method used for the performance modeling of the fault tolerance system, the Quasi-Newton method, direct search method, quite commonly used, and many soft computing approach are used for the optimization purpose. So that is the genetic algorithm, PSO, harmonic search, cuckoo search, and many. It is in hundreds of the techniques are available, but commonly used techniques are these. So how we take the performance measures? So some more features, time assumption should be taken into consideration. Redundancy is required for the fault tolerance system in hardware systems. And even for the fault tolerance system, we are using the redundancy. And maintainability means we should cover the fault by providing the repair. So that kind of maintainability is used. However, if there is not much fault in the system, the repairman may be free, so it can be go for the vacation. So that kind of the provision is done in the model. If working vacation model is the model in which we are having the provision of the working vacation means during the vacation the repairman can provide the repair with lower rate. So say we are having the sleep mode in case of the our cloud computing system. There is the active mode and sleep mode of the server. And working breakdown means if there is a partial failure, the system can work. So that provision can be done to develop the fault tolerant system. Reboot and recovery is very common use technique in the computer communication system in many real life systems, other systems also. So whatever switching from good to bad state. So whenever system is failed, switching may be that is the removal of the faulty unit may be the incorrect. So that is the imperfect switching. If repair is not done correctly in the first step, this is called the imperfect repair. Or imperfect coverage means there is detection of the fault is not correctly done. So that is imperfect coverage. So that kind of the realistic assumption should be involved. Common cause failure may be there. At a time, more than one unit fails. Common cause may be the due to the humanity, maybe the some say earthquake is there or some flood is there. So many components may fail together. So that kind of things is taken into consideration. So we take the quickly a model. This is the five nodes system. 5 states are there. So here the provision of the reboot imperfect coverage is taken into consideration, and we develop the equation for the fuzzy model also. Sorry. Then parametric non-linear programming method is used, that is based on the alpha cut. So this you can easily formulate the equations because if we are having this kind of the transition diagram, 5 units are there. Lambda S is the failure rate of the your standby units, and lambda is the failure rate of the operating units. C and CS denote the coverage probability of the operating unit and the standby units. So from we take the transition diagram into consideration, and you can now easily formulate the set of governing equation for these 5 state. And the second diagram shows the provision of the reboot and recovery, where in the first we don't have the reboot and recovery into consideration. So this is sigma and gamma, these transition. This is the rate of the reboot and recovery respectively. So once we are taking the governing equation by taking the inflow and outflow from each state into consideration, then for the transient state we take the Laplace transform of those equations, and then we take the solve that one simultaneous equations. So easily we can do, because this is a 5-state system. Some algebraic difficulty may be there, but we can solve this in explicit form. So Laplace transform of these states are there. And for this system, you can get the reliability. You take the inverse Laplace transform of these Laplace transform probabilities, then get the reliability. Reliability is the probability the system is in functioning mode. So based on the figure, we can see the Yo's state 0, 1 and 2 are the functioning state, where the 3 and 4 are the down state of the system. So sum of the probability of the functioning state gives you the availability and the reliability of the system. There is a uh, uh, this formula for the mean time to failure. This we take the integral over the duration for the of the reliability. So for 5-unit system, we can easily get the performance measures, and then we take the sensitivity analysis by setting the parameters. So not only setting the parameter, here we set the default parameter into consideration, but if we have the real-time data, we take the parameter estimation. Commonly used technique is the least square method, or we are taking the maximum likelihood approach, and more advanced method, EM method and other methods can be used. So this is the trend, how we depict the mean time to failure with respect to the some parameter, that is a lambda, and lambda is the failure rate, mu is the repair rate, and C is the coverage probabilities. So for this is model where we have only 5 state into consideration, we can take the sensitivity analysis, and fuzzy-fied parameter can be tackled with the help of the alpha cut approach used for the fuzzy parameter, so mean time to failure and so on. So whatever results is here, you can see we get the output as a fuzzy output. So this output mean time to failure and the availability is depicted in terms of the membership function. But to take the crisp value of this fuzzy matrix, we have to take the sub formula for the defuzzification also. So this kind of the fuzzy output comes into the some fault tolerance system. Say this is the washing machine or maybe the yours AC. So then we provide there some defudgified parameters, means crisp parameters to set the temperature in AC or the whatever program for the some other devices. So if we have the more advanced features into consideration, we have the service interruption due to the failure of the server or imperfect coverage or the reboot. So this kind, we have the large number of the state. So say now we are familiar how we take the different state into the consideration, and by taking the transition from one state to another state and write down the equations in terms of the use inflow and outflow, we can formulate the set of equations and then solve by using the analytical method or the numerical method, and optimization by using the soft computing approach. So you can see for this model, we have the sum label, 0 operator, whatever repairman is normal busy state, it provides the repair. It may be the on vacation or it may be the breakdown. And during the all the three state, there is a case reboot state is also there. So say this is the reboot recovery. We have the, in this case, we have the fault is not detected. So there is the provision of the reboot. Beta is the rate for the this one. And in the this 0 label means if repairman is the normal busy state, so we have the here is the fault coverage perfect, and if it is not perfect, go to this state, then there we have the provision of the reboot. So reboot is taken in all the three labels when repairman is busy, normal busy, vacation or breakdown state. So this kind of the model we can develop, and again the same way as previously we take the formulation of the governing equations, then taking the Laplace transform. If it is a transient solution, we can get the results. So you can see the in terms of the transient probabilities for the each state, we get the Laplace transform. This is the equations, Laplace transform of the governing equations. And but here we can apply the spectral method because large number of the states are there. So we write down this simultaneous equation in matrix form and then use the spectral method. Spectral methods means we are taking the eigenvalues into consideration and get the Laplace transform values and then take the inverse Laplace transform and get the reliability and mean time to failure into consideration. So sensitivity analysis is also important. So how parameter vary with respect to the input parameters that we can do for the mean time to failure as well as the reliability. Relative sensitivity analysis is also important for the continuous parameters. For the discrete parameter, we can take the change in the parameter in discrete way. But if parameter are continuous, we take the derivative into consideration to get the sensitivity analysis. So for this model, just we formulate the total cost, and by doing the optimization, we can get the optimal value of the repair rate into consideration. So you can see the performance measures, not just last topic we discussed, that is the non-Markovian process. Earlier we developed the model for the fault tolerance system where the states are the Markovian, but sometimes states are the non-Markovian, that in probability or distribution terms is not governed by the exponential distribution, So MG1 means M is the failure is in Poisson fashion. G depict that the repair time is generally distributed. 1 means one repairman is there. So if we take this model along with the provision of vacation, perfect recovery and the reboot delay, so that then we take the transition diagram here, but here Markovian property is not satisfied, so we use the supplementary variable technique. What is the advantage of using the supplementary variables? Here we take the uh, repair time as a supplementary variables. So whatever remaining repair time is taken as a supplementary variable. So this make the non-Markovian process to be tackled easily. So this kind of the things can be done. So we are not much interested. So the model can also be developed when there are more than one kind of the failures, or the state may be the server may be on the working vacation. The advantage of working vacation is that we can have the some economic system, because if server is on vacation, this is a loss to the system if some units are coming there. So in case of the working vacation, the repairman can also provide the service. So as we done in the previous case, we have the set of equations, and for the steady state, we can take those set of equation in matrix form, and then by using the matrix recursive approach, we can solve the probability distribution, that is the value of the probability, and get the performance measures. So this is again a one more advanced model. Here we take the many things into consideration. F policy. So what is the F policy? F policy is if system is full, in that case the inflow of the failed machine is not permitted till the number of failed machine in the system drop to the some label, F label here. So this is one more realistic assumption. So, but number of states and number of labels becomes the very large. But by using the numerical approach or the spectral methods, this can be tackled. But complexity is there. So the nowadays we can also apply the AI method once we are getting the performance measures. Then with the help of the real-time data, we can develop the AI-based formula to take the performance measures. So whatever I discussed, we have taken the several real-time concept to develop the fault tolerance system, and to develop the model. Fuzzy logic and soft computing approach can be used, and we have applied that one. But for the forecasting purpose, we need the regression analysis, as in statics people are using. But nowadays we are having the many AI technique, say random forest method or the support vector machine, etc. We can use, because we need the output very quickly for the real-time systems. And in spite of the failure of the system will work. So this is the main objective of the fault tolerant system. So that can be fulfilled, but system should be economic. So for economic system, we have to take advantage of the working vacation or the broken down servers. If it is partial failed, it can provide the service to the system. So steady state results can be tackled easily by taking the matrix equations But for the transient, it is very, very difficult as number of states increase. So whatever I have presented, so this fault tolerant system is also applicable to develop the devices for the agriculture, and also whatever soft computing approach can be used to take the optimal parameter into consideration. Thank you so much. So if you have any query, or I can. Hello, I stop here. If you have
Dear
any question or
participants,
query.
you have any query? Okay, thank you so much, ma'am, for your valuable lecture and sparing a valuable time for our conference. Thank you so much.
Thank you for listening me patiently. And I am thankful to all the participants and the distinguished delegates present who are present in this talk. Thank you so much.
Okay. Next.
Mic is on. Good afternoon, everyone. On behalf of the organizing committee, I warmly welcome you all to second keynote lecture session of this conference. My name is Rajesh Bisht and I will be chairing this keynote session. It is my great pleasure to introduce today's keynote speaker, Dr. Jairaj Nityanandan. Dr. Nityanandan is a senior principal scientist at the Physical and Material Chemistry Division, CSIR National Chemical Laboratory, Pune. He obtained his PhD in organic chemistry from the IISc Bangalore and has also carried out postdoctoral research in University of Miami, United States. His research interests includes organic synthesis, organic photochemistry, supramolecular chemistry, photosynthesis, photoresponsive materials, and dye-synthesized solar cells. He has published extensively in leading international journals, holds patents, and is a recipient of several prestigious recognitions, including the Marie Curie International Incoming Fellowship. We are honored to have him with us today. I now invite Dr. Nityanandan sir to kindly deliver his keynote lecture. Sir, please start.
Good morning to all of you. Am I audible, Rajesh?
Yes, sir. Yes, you are audible to us.
My slides are visible, right?
Yes, sir. They are visible.
Okay. Good afternoon, all of you. First of all, I thank the organizers for this nice opportunity to present some of the thought process and some of the research activities that we are exploring in NCL Pune that can be used to, in the agricultural sector that have been currently pursued, even though we are not pursuing, but the research direction has been used to explore some of the technologies on photovoltaics in agriculture technology. I will slightly touch upon these activities, then I will provide some of the results from our lab. So once again, thank you for listening to me, and thanks to the organizers for having me here. So I just try to put together my talk as dye-sensitized solar cell for agri-photovoltaics. Before going to it, just giving a thought of course, today, Professor Ramanujan's birthday, similar along the line, 100 years back or 120 years back, there's a scientist Xiaomi Chan. He predicted that solar energy is going to play an important role in the future. That he did it about 10 years ago. He's from Italy, so that as long as sun shines, we'll be having the civilization will be continued. So that's what he said. Currently, that one of the aspects that we have been we have been pursuing for decades or even centuries to understand the thing about photosynthesis. Like, of course, when we study in our undergraduate or school time, we can say that, photosynthesis is a process where carbon dioxide has been used to convert to glucose in the presence of water. And, but the essential criteria is the light that comes from the sun. Of course, here you can see the lot of organic molecules. I'm sure that that can harvest the light. I'm not it's okay not knowing the name of the molecule, but there's some organic molecules that can harvest the light in the sense that they can absorb the light and then convert it into usable form of cleaning the water. Okay, so that's what that does is, this is just I'm showing the absorption spectrum, where of course in the sunlight we have different light, different photons that can be especially we will be more focusing on invisible as well as NIR light. Of course, you have UV as well as you can go on. The electromagnetic spectrum is very widespread, but mostly we will be focusing on the visible light. That's where, or like NIR light, that's where these molecules absorb the light and convert them into a usable form of energy, which can be used to clean the water. Basically, here, like in a very basic thing, basically like water gets into there, and there are a lot of light absorbing complex that you are seeing, and that is converted to oxygen. Further, the water is also giving the proton and electron. Water is getting oxidized here. Then that is used to convert the carbon dioxide to glucose. Basically, that's a dark reaction. This is a light initiated reaction. If you want to get into more detail, for example, molecular level, what's happening, this is what it looks like. Of course, there were more than 12 Nobel Prizes on this topic. Basically, some scientists are looking at the structure of the protein, and some scientists are looking at the electron excitation, this light excitation, how the energy is moved to, even though the light is absorbed by one complex, and how it is reached to P680, and how it is used to clean the water, and how the electrons are getting transported, how the protons are getting ATP or ADP is converted into ATP. All these things are put together. There were more than 12 dozens of Nobel Prize across the various science disciplines. It can be biology or physics or chemistry. Okay, but today I'm going to talk about something I'm going to use this picture, but this is a kind of population picture. That I took it from the website Our World in Data. That you can look at it. Especially I want you to draw the attention how the population has been increased over the years. Okay, but if you see very carefully, there's a drastic jump near around somewhere around 1950 to 60s. From there on, it's like population increases is exponential. Okay, of course, thanks to the pharma industry, as well as there's a great the finding a way to convert nitrogen to ammonia, Haber-Bosch process. Okay, these two things have played a vital role because of it we could be able to sustain it, because for example, from ammonia you can generate urea, from urea to fertilizers, then agriculture blooms. Of course, in terms of chemicals, you have a lot of pharma, so that the life expectancy also increased. Of course, a lot of insecticides, so that all these things put together, the earth, we could be able to sustain this kind of enhanced population, and it's keep growing. Now, this is something like 2020 data, whatever I presented here. But if you go down, this is a present a couple of years back. If you look at it, this is the world population. And we are in India or China, all other in Europe or United States are here. So in order to think about how to sustain as well as how to feed all the population, one of the thing is we think of agriculture, as well as also not even that, we need energy to sustain also, because nowadays in the modern era, we can have very wide utility of electricity in different forms. Okay, of course, all of the energies are coming from coal or it's a natural resources that we have been depleting. As a consequences, Of course, this is the kind of, as I said, the life expectancy of like average lifetime of a man as well as a woman is improving because we have very good healthcare system compared to like, of a decade, like, a century before. And at the same time, we have been using a lot of energy sources. For example, like 1950s, we are using only natural resources. And like, of course, the energy of like, of course, we have traditional biomass, coal, oil, natural gas. Of course, the top 5 things are keep improving. That is something to do with renewable energy sources. That means that, we can use other resources to produce energy without using much of the natural resources. Like, that's something very interesting. And the future is going to be rely on mostly on the renewable energy sources, especially the solar, wind, hydropower, and everything, right? Of course, this is yet another thing we also keep in mind. At the same time, like, every time I'm spending here, like, there's output is carbon dioxide. Like, whatever we do, little things, the output is carbon dioxide, because of which the annual production of carbon dioxide has been dramatically, like, enhanced from 5 billion tons in somewhere around 1950s. Now we have somewhere around like, 40 billion tons. That's a huge. Of course, the thing is, whatever we do, the way we breathe, or the way we ride our vehicles, or the way we touch our mouse pad, the output is like carbon dioxide. That's where it is, and it's keep increasing. By considering all these things, like, we need to think about a solution that could, like, in order to sustainability, we need to find a way to enhance the renewable, sector instead of using the non-renewables, so that, like, at the end of the day, we need to give the earth to our future generation the way kind of it is now, so that, the things can go on. So one of the things, like, here very things are happening is that the renewable sector, like biomass, hydro, or geothermal, wind, or solar. Of course, like, there is some kind of like enforcement in nuclear energy, but of course that's very limited and geography specific. And this where the solar energy finds a very good potential contributor to this energy production sector. Of course, the sun, yes, the thing is, very nice thing about solar energy is, like, the light input is our, it's a great. Of course, in the, if you consider kind of, the layman say 1 hour of sunshine has more than enough to satisfy human demand for entire year. Okay. Like, that's that much energy, like, sun is pumping to the earth in an hour, every hour. Okay, that's a great potential. But again, the interesting research is how to harvest, how to convert, how to store it. All these things are matters. And of course, like, at the end of the day, we need to avoid the material that causes greenhouse emission, like, carbon dioxide and other things. And of course, the solar cell is a viable, because I'm sure that many of you would have witnessed the solar farms around your place. Of course, it's again, like, what you want to do with that. Like, it's a kind of, it's a kilowatt or megawatt. Recently, there has been a lot of interest in developing solar cell that can take care of very, like, kind of low energy sectors. So for example, RFID tag, remote sensor, like, where we don't have to produce like batteries or capacitors. Rather, like, we can use silicon, not silicon, like, there are other technologies that you can think of using to fulfill this energy requirement in this sector. So the addition to it, last maybe close to 10 years, there people are also thinking about agri-photovoltaics. For example, the food demand as well as energy demand is parallelly increasing. Like, if you consider with the current population, we also need food. At the same time, we also need energy. Okay, the one way to think about is how to integrate photovoltaics as well as this agriculture. Okay, we need, like, for example, in order to make a solar farm, you need space. Of course, the agriculture also we need a we need a dramatic amount of the drastic amount of space. So if you put together, the idea is you put together like with a lot of understanding about the photovoltaics as well as the kind of crops that you want to do. Like you can have synergistic effect of both agricultural things as well as energy production. So that's the idea. Of course, it's having like the carbon neutral soil, fertilizer soil, or like a water, or like enhanced biodiversity it can also offer. So this agri-photovoltaic addresses the land use sustainability challenges by like integrating both agriculture as well as photovoltaic activity. So that's where it is kind of in this sector is coming up. For example, the advantage is, for example, water. In the case of agri-photovoltaics, it's like, because you are basically you are drastically reducing the temperature. Just like, that's one of the idea behind the agri-photovoltaics. For example, if you consider in the normal field, like, the sun is exposed all over the field, and of course, the high rate of water evaporation. Whereas in the case of agri-photovoltaics, what you can do is that in the field, you can also systematically plant these solar panels so that it can provide some shades, and also it can reduce some kind of like a temperature, and it can also avoid the unwanted the causes due to the temperature, basically kind of flowering or like other things. So that's where it's happening. But the energy, basically, like in the case of agri-photovoltaic, you can have the on-farm electricity production also one can think of. And food, actually, the food, the production is like, it's kind of really enhanced. Even like a recent result says that almost like a 200%, okay, of a particular crop. If you do it in the agri-photovoltaics, than this normal photovoltaics. So that's something very interesting. Of course, that you need to have a lot of design. Of course, it's kind of it's a growing field. You need to think about site selection and crop analysis and the defined growth period and environmental conditions, basically windy or like, again, the orientation of the solar cell. So all these things one has to understand depending upon the place, and the modeling in the sense that how how we can space the solar modules, like, so that we can have the better production. And of course, suitability of for different crops. It's not that one good for like everything, that we need to spend like some kind of analysis. Of course, the research is in very good shape. Maybe within another like a decade time, there will be a lot of activity along the line in the real day applications. Of course, the idea is something like, I kept it very like, of course, I took it from the internet, all the figures, but you can see that the crop production supporting water conservation, soil retention, carbon sequestration, and biodiversity. There are a lot of advantages is there. Okay, of course, like, you can think of, there's a lot of modeling has to be done, so that like depending upon the product, how much the spacing between the solar panels has to be provided in the given land. So, for example, here, how much transparency. When I say transparency, there's a lot of like, of course, there are greenhouses are available now in order to control the temperature. We have greenhouses for the last like several decades, but now one has to integrate instead of greenhouses, how these kind of agri-photovoltaic also is going to give additional benefits to this kind of agriculture things. So with this, like, I'm going to give up some idea about what is solar fuels, photovoltaics, and solar thermal. Of course, this is somewhere, how we are mimicking the photosynthesis. Is all this research, in the photochemistry or organic synthesis, to see that how one can mimic the nature. Okay? Like, what nature like does is that the leaves, it takes the carbon dioxide and water, and in the process of sunlight, it gives the oxygen as well as glucose. Whether the same thing can be mimicked by using this, nanomaterials or chemistry. Like, here, in 1972, they showed that the TiO2, one of the inorganic material, can do the same job, okay, by using the sunlight. Of course, the efficiency is very poor. That's where, like, other areas come in, like how to enhance the efficiency by enhancing the light absorbing material. Basically, TA would absorb only in the UV region. The UV region, the sun, the only 5% of UV light is present in the sunlight. Okay, that again, it's a region specific. So one have to think of how you can enhance the light harvesting property by using synthetic or designed organic or inorganic materials. Of course, like there is a lot of activities are happening. What we are talking about is the water splitting, that the previous things, but now there is tremendous effect in using carbon dioxide as a starting material. For example, the carbon dioxide capture, utilization, as well as sequestration method. Like India has given a roadmap in the last week, especially the DSTA, Department of Science and Technology, has come up with a roadmap how to use this carbon dioxide. Of course, as I said, we have plenty of carbon dioxide around. Every year we are also producing huge amount of carbon dioxide. So there's a lot of course, plant does it something like that. Whether we can do some chemically, because we are not going to wait for the plant to grow and convert carbon dioxide to some other material. Whereas some catalytic method, some chemical nanomaterials that can also convert carbon dioxide to some usable chemicals, for example, methanol or acetic acid. So they are like a very precursors for making other chemicals. Okay, so that's where one of the research is happening, and as I told you, there is a lot of interest in developing photoelectrochemical cell or for hydrogen production. That's one of the key. Even NCL, this slightly old slide. I kept it for purpose because sometimes we start as a very basic research, and I can tell you one thing. Last year, early this year, even NCL is having a method to produce hydrogen, and that can support a catamaran or other e-vehicles. Okay, but of course that is produced by some other methods. But the idea is to generate the hydrogen from water and other materials. Of course, there's also a lot of interesting inorganic materials that can do the job. It's like a leaf. You don't have to have cell. You just take a kind of thin sheet coated with a photocatalyst on a conducting material. Then you can beautifully generate a hydrogen. It's like a kind of, you can access like a kind of electrolyzer. Okay. Of course, there's a lot of inorganic compound also plays a vital role, because inorganic compounds as well as organic hybrids play a vital role, so that the energy harvesting can be done by an organic molecule, and the water splitting can be done exclusively by the inorganic material. So that's also one of the active area. So this is when you look at the sunlight, the light distribution is something like this. You have 5% of UV light, that is something like less than 300 or 400. This region you are talking about. And if there is a 46% of visible light, that's where most of the lights are available. And of course, you have NIR. If you have far red and NIR, it's because of the heat and everything. There's almost a 49%. Okay, so this is a kind of energy distribution in the solar spectrum. And of course, people thought about it, how to convert the solar cell or solar energy into electricity. It's very old, when they found out this electromagnetic induction, the research started along the line, how to convert the solar energy to electrical energy in the form of photovoltaic effect. And now the very good the outcome of all this research is the silicon solar cell that came in 1960s and immediately captured the market, and now we can see everywhere. But one of the things is that we need to have high purity silicon to do the job. Okay, the way now the present cell is that silicon, we talked about the first generation solar cell. Of course, after that, there is a huge interest in developing second generation solar cell that's called thin film solar cells. Of course, that's where the energy is very high. The efficiencies we can reach up to 47%. Since the cost as well as the materials involved are very expensive, these solar cells have been used for satellite applications, so that for the launching applications. Of course, the last one is that emerging photovoltaics. That's where we were interested, because that's where we said like a dye sensitizer solar cell, perovskite solar cell, as well as organic solar cells and quantum dot solar cells. The efficiency are like close to like a max at the max. Like with perovskite, one can reach up to like a 27% now, and other solar cell one can reach up to 20%. But the good thing about all this third generation photovoltaics is it can work with diffused light, in the sense that even in the indoor application you can draw a very good current. Okay, we don't have to have very constant or like a very good light like as we have in the 12 noon in the afternoon, 12 in the afternoon. Where we can have these kind of third generation photovoltaics. We can make it very flexible, and we can put it in the indoor, so that we can use it for some other applications. Of course, this is a typical way of how a first generation solar cell works, like a p-n junction. We have p-doped and n-doped, like a semiconducting material, and when you shine the light, the electric field develop within the system, give you the potential. And because of that, like the charges are separating out, so that like you can have a current output. Okay. And what we are focusing here is this solar dye sensitizer solar cells. Of course, this is a device. This is a organic and inorganic a hybrid material coated on a conducting substrate, and that can access a photoanode. Just basically the dye absorbs the light. And of course, this is separated by a cathode. And in order to have a charge moving around the system, like we need to have an electrolyte. Okay? And of course, the way it works is the dye absorbs the light and gives the electron to the TiO2, and the same time the oxidized dye is getting oxidized dye is kind of regenerates the dye, so that clearly do the charge separation. Okay. Of course, one can vary these parameters like VOC with different aromatic or other electrolytes. So here where there are a lot of nanomaterials play a role, whether you can have nanoparticles or nanofiber or aligned nanorods, so that the charge transport will become very efficient. Of course, here this is where we make the device. Like we can have a photoanode, and that can be like basically a conducting substrate on which the TiO2 is coated, and it can be sensitized with the dye. And further, we can sandwich between this counter electrode, basically a platinum like a nanoparticle coated conducting surface. That gives a kind of your cell. Then we can carry this IV curve. Basically, you can put it under the cell, under the solar simulator, and how the cell works with a different voltage, as well as how the IPC works. Basically, IPC means incident photo, like incident light to photocurrent generation efficiency. Of course, there are a lot of parameters involved: how the light harvesting efficiency, charge injection process, charge collection process, regeneration process, that we can be kind of controlled, and we can design the dyes based upon this. So these are some of the dyes that is known in the literature that gives like a very fantastic efficiency. And the way in our lab we develop a lot of dyes basically to understand to take care of dye sensitized solar cell or supramolecular chemistry, or we can have also the photoresponsive materials. Okay. Of course, we specifically take care of the dye TiO2 interface. Basically, that's where the charge separation happens. Okay. For example, that is common in the natural kind of photosynthesis system, or it could be solar cell or dye sensitized solar cell or quantum dot solar cell. The thing is the charge separation, the initial charge separation at the dye and the TiO2 interface. That's very important. And again, it was I showed in behalf, like third generation photovoltaics reaches up to the device performance of 15 to 27. That is a DSSC or But one of the nice things about is we can make a flexible device out of it, as well as we can make
ওই
a.
অ্যাকাউন্টেই কিন্তু টাকা মানে আমি যেতে পাঠিয়েছি
Of course, this is the various time scale that I am given. So we develop the dice basically like these things are very good. Like it's always a very fast process. Whereas in this electron transport and interfacial recombination process are the kind of tool that we can use it to design the dice. Okay. Of course, in order to understand how the organic molecules bind to the TiO2 also very important because that decides the fate of the device, basically, and how the monolayer formation, how the die forms the monolayer out of the TiO2 surface, and what kind of interactions. Basically, interaction in the sense that the die can aggregate. That gives the die aggregate means that two molecules can come together. That gives that different kind of arrangement. And the photophysics of such arrangements also changes. Basically, you can take the idea is we can take a one molecule and you can spread the absorption spectrum because of the aggregate, whether like a H aggregate or J aggregate, or like, as I said, like whether it's a head-to-head or head-to-tail alignment of the dipoles, you can spread the absorption profile of the sensitizer, even though you are using only one sensitizer. Okay. And we also design in such a way that some of the unwanted, like a charge recombination process that we want to avoid, that so that we can keep a alkyl group to passivate the TiO2 surface. So we designed that these dies basically, for example, by systematically increasing the steric factor around the square dies. Of course, we do with various synthesis, and which I'm not going to talk about it, basically how to build this molecule in an organic chemistry way. And when we look at the photophysics, all the dyes show similar spectroscopic properties, whereas the SQ1 and the SQ5 show different spectroscopic properties on the TiO2 surface because aggregates formation. Because, and as I said, this aggregation causes the spreading of the spectrum of the sensitizing capabilities of the sensitizer. But one question is remaining that whether this process can be useful for photocurrent generation. That's a question we asked from the beginning, and we realized that such a kind of sterically appended dyes shows slightly better photocurrent generation. Because these dyes can aggregate as well as passivate the TiO2 surface very efficiently so that the device performance can be improved. Like for example, the same dyes, only one with some kind of steric factor that gives like a slightly better efficiency. And of course, one can change the, we can do systematic study on this kind of things to match the light harvesting property as well as IPC pattern. Okay. Further, we can also change the alkyl groups so that the photocurrent generation from aggregated state can be achieved. But to be like I can say this point, this is very important because nature does it, all the photosynthesis is not from a monomeric dye. Okay, the light harvesting process is eventually happening from the aggregated state. So that's something, in a way, we are mimicking the natural photosynthesis system by designing this kind of synthetic dyes. Okay. Of course, one can change the photovoltaic effect by light harvesting, the solvent that we use it for light harvesting process. For example, if you use acetonitrile, we can have the very broader IPC profile. Whereas if you use very good solvent like chloroform, the photovoltaic effect is kind of drastically changed. Basically, you can dictate how you want that the device has to perform. Whether you want to have the contribution from the aggregated state, then you need to use a bad solvent. Or if you want to use a very good solvent, then so that the dyes are very happy in a monomeric level, so that the aggregate, you are not taking the advantage of the aggregated state, even if you are sensitizing for more than 48 hours. Of course, Rajesh has developed a set of dyes, who organizing one of the organizing committee of this conference has developed one of the nice set of dyes that he showed that the aggregate is still good for generating photocurrent. Of course, he found a J aggregate, the indication of the J aggregate in this particular work. And what we did was further, we chopped down this modification to the structure. Basically, we remove the, we remove the like a conjugation, extending the conjugation or reducing the conjugation, by which you can shift the absorption spectrum to the visible or to NIR. And in one of the dyes, what we developed in this particular one is this is a visible dye active dye, whereas this is a forward active dye. We can mix together so that we can have a better device performance, basically from absorbing light from 400 to 700 nanometer. Okay, that's something like we could able to modulate. And recently also we have showed that by similar chemistry, you can develop dyes from visible, far-red, NIR regions, so that by same kind of square and dyes, so that I want you to draw this attention. Basically, this is a colorless dye, even though this 850 nanometer absorption dyes are colorless, but still you can use it for some kind of photocurrent generation. The efficiencies are very low. Here, if you see carefully, if you're going from this visible to NIR light, the device performances are low because of there is some kind of alignment of the energy levels. But this is a kind of beginning starting point where we have to optimize several other factors. Okay. Of course, we are using this kind of sensitizer for using indoor light applications. Of course, we collaborated with Dr. Suraj Soman in the NIST Thiruvananthapuram, and the similar dye we can use it for 100 lux. Basically, like one sun is something like a 1,20,000 lux, but here we can think of 50 lux, 100 lux. It's a kind of even lower intensity than the room light that we have now. Even these cells can perform very nicely, and it can be used for charging some of the electronic gadgets in the indoor applications. Okay. With this summary, I summarized this work. Basically, we could, I just showed some kind of introduction to some of the recent activities at the recent development in this area, especially the agri-photovoltaics. And what we do here, in the dye sensitized solar cells, of course, how this technology can be used to agri-photovoltaics, that's what we are exploring, because these technologies are very cheap compared to the existing silicon photovoltaics or like a perovskite photovoltaics. With this, I thank my group members, without which I could, I have not done this work. They are the, force behind all these research activities. And I just want to show one of the earlier photo that we showed where Rajesh was there in our group. And these are some of the outcome of our research group. Maybe if somebody want to have any interaction, I am very happy to have it. With this, I'm stopping my presentation. If there is any questions, I am very happy to answer. Yes.
Thank you very much, sir, for that insightful and engaging keynote lecture.
Yes.
So we do have some time for a few questions. Participants may kindly use the raise hand options.
Yes.
बता देंगे डॉक्टर आने के डॉक्टर से आपको बता देंगे क्योंकि लॉगिन तो हमने अपनी उससे कराया तो वही चलानी पड़ेगी।
Participants can unmute themselves if they want and want to ask a question. I think maybe I'll ask a question, sir.
Yes.
If that's okay.
Yeah, please.
So what do you think are the major challenges in translating this laboratory scale DSSC research into real world applications?
Yes.
Because since I'm in agriculture university, sometimes it strikes my mind that if we can use a greenhouse or glass house,
yes,
which uses a lot of light to capture heat, would that become of something related to DSSC?
Right. Yeah, it's a good question, Rajesh. I think in the recent effort, I think I can tell you one thing. Last 2 years, we have been involved in a FTT project, the fast translation and fast track translation project, where we need to scale up the devices. Fortunately, in that CSIR NIST Thiruvananthapuram, they have the facility. Now they can make something like 10 centimeter by 10 centimeter cell 100 per day now. Okay, so then the idea is, for example, if you go to an airport or any common place, there are a lot of lights are available. Okay,
yes,
but to capture that light and use it as a kind of humidity sensor and other thing, Of course, we play a little role. We advise them to make which can go get into the device and what's the stability, all these things. But there are some big projects are coming up along the line where like these cells can be used to make the building integrated photovoltaics. Okay, where some of the the glass windows can be used. We can that be glass window, but still we can use to harvest the light and convert it into electricity. But these things are coming up. Maybe it may take another few years, maybe 4 to 5 years to see some of the things in the commercial aspect. But it may not be that much time because there's already startup working on this project.
Okay,
Soon there may be an outcome. Yeah.
sure, sure. Thank you very much, sir.
Yeah.
Is there anyone who wants to ask a question? They can unmute themselves. I think that's all.
Okay.
So thank you again, sir, very much for this excellent lecture and for sharing your valuable insights with us.
Yeah.
I also thank all the participants for their active presence and interaction. With this, we conclude this keynote lecture session. So thank you very much, sir.
Yeah. Thank you, Rajesh. Thank you.
So,
Thank you,
yes,
the organizers. Yeah. Thank you all.
thank you. So we now we break for lunch until 1:30 p.m. I request all the participants to kindly rejoin the session on time for the next academic program. Following lunch break, we will have flash presentation session. I request all the presenters to keep their presentation ready and ensure that their audio, video, and screen sharing are working properly. Kindly note that strict time limit will be followed for flash presentations. So with that, we'll see you soon after 1:30.